Hello developers and architects, and welcome to another video on building serverless applications on AWS. In this video today, we're going to look at running web applications on Lambda. Now, I shared a tweet earlier this week about running APIs on Lambda, and older me used to think that a single purpose handler equated to a single route on an API mapped to a single handler. But actually, the more and more I'm speaking to people, the more and more I'm building with Lambda, I don't think this is the right approach. And actually the better approach to be having a single Lambda, a monolithic Lambda function with a set of endpoints in it grouped around a specific piece of functionality. So you might have a user API Lambda, a product API Lambda, and an orders API Lambda. And within that Lambda function, you'll run a single process that handles all of your different API routes. How do we do that? How can you run a web application on Lambda? Well, let's find out in this video. Let's get to it. I am super excited to announce that I've launched my second course on the Dome Train platform. This course is a getting started with microservices, the biggest buzzword I think possibly the tech industry has ever seen. And in this course, you're going to learn the fundamentals of building microservices, agnostic of programming language or cloud provider or compute. The things you need to know to make sure you are building microservices correctly. Architecture patterns, integration patterns, shipping, testing, deploying, and importantly, the organizational side of building microservices. Yep, some things that us techies don't really like getting involved in, but things that are super important for your journey to microservices. So there's a link in the description below if you're interested in this course. For a limited period of time, there is a discount code. The first 500 signups will get that discount. So please jump, grab the course, let me know any feedback, and I'd love to see what you think. Thanks everyone, back to the video. So to actually look at how you can run a web application on Lambda, let's first revisit exactly how Lambda works. So over at one side here, you've got your actual Lambda function. This is your application code. And then over here, you've got your API. This might be API gateway, this might be an application load balancer, but there's some API that your users can make requests to. Now, when an API invokes Lambda, it uses what's called the synchronous invocation model. And that is where your API will make a call to the Lambda APIs, and API gateway will sit and wait for a response to come back. It's synchronous. API gateway obviously needs to see that response. Then the request is obviously passed from the Lambda API onto your actual Lambda function. And most of the managed runtimes in Lambda work by polling some kind of runtime API. So here you might have the runtime API. So when the request comes into Lambda here, the execution environment gets created over here, and then the Lambda function polls the runtime API to actually get the event payload that came from your API over here. So although it is synchronous and push-based, your actual Lambda application code running over here is polling the runtime API to actually get the event payload. So to run web applications on Lambda, all we need to do is actually poll this runtime API. And of course, there is already a tool out there you can use, and that's going to be the focus of this video. And that is the Lambda Web Adapter. The Lambda Web Adapter functions much like a proxy sat in front of your application code here. So you've got your Lambda function still over here. You've got the request coming in to your Lambda function, and you've got the Lambda runtime API running here. And what the Lambda Web Adapter does is it runs as a Lambda layer sat between your code and the actual runtime API. And the Lambda Web Adapter is going to poll the runtime API on your behalf, and it's then going to make an API call to your actual web application that at this point might be running on HTTP, localhost, and maybe it's running on port 8080. So now the Lambda Web Adapter is actually going to handle that interaction with your web API. So your web application is up and running inside that Lambda execution environment, and the Lambda Web Adapter is handling that request response and then passing the response back to the runtime API, which then goes all the way back out here to your user who called your API in the first place. Sounds fantastic, right? Well, let's actually have a look at how that works in practice. So what I'm going to use to demonstrate this here is a Rust-based API. Now, I know typically I do things with .NET or things with Java. .NET and Java have the luxury of having libraries that can handle this already without a need of additional layers. So in .NET, you've got the Amazon Lambda ASP.NET Core server packages, and in Java, you've got the serverless Java container, both of which I've got videos on the channel. I'll put links in the description below for them. So let's use something a little bit more interesting. This could equally be a Flask API, an Express API. I'm using Rust and Axum here, which is a framework for running web applications. The actual contents of my web application are largely irrelevant. All that you need to know really is that when this application starts up, it's going to start up on localhost. So it's running on port 8080. So when I compile this Rust application, I'll get an executable. I can run that executable, which will give me an application running on port 8080. That is it. If you're using Express, if you're using Flask, any of these similar web frameworks, that is all you need to ensure, that when your Lambda function starts up, that it runs on a certain port. And as a default, I'd recommend using 8080. So where things get interesting is if I actually look at my AWS SAM template. So I'm using AWS SAM to deploy this. This could equally be the CDK or Terraform or raw cloud formation. If you really want to do that, don't do that, please. And I've actually got my single Lambda function here. So you see I've got one single Lambda function. Let's just zoom this in a little bit so you can read this. I've got a single Lambda function defined in my SAM template. Of course, I'm using Rust, so I can use the Rust cargo Lambda build method to actually compile my Rust application with SAM. Where things get interesting, however, are down with the handler and with my Lambda layers. So because I'm using a custom runtime with Lambda and I'm using Rust, the actual handler is always going to be Bootstrap. So this handler string here is largely irrelevant. The custom runtime is just going to look for a file named Bootstrap, and that is what is going to be executed. So the request comes into Lambda, it'll execute the file called Bootstrap, which in this case is going to start up my Rust API running on port 8080. Then I've also got this Lambda layer defined, and this is where the magic happens. This is what comes from the Lambda Web Adapter. This actually starts up a little Rust-based application as a Lambda layer. So that's going to run next to your actual Lambda function code, if you will. And when your execution environment is started up for your Lambda function, this layer will start up and that will start polling that runtime API on your behalf. It's going to poll the runtime API, pass on and make a request to localhost 8080, which at this point is going to be my handler running here. And remember, this could be any web framework you choose, providing you can start it up on localhost from an executable. And if you actually go and have a look at the GitHub repo for the Lambda Web Adapter, there are a whole bunch of different examples in here: ASP.NET, Express, Fast API, Flask, Gin, whatever the heck Gin is, NGINX, PHP, literally anything you can think of. There are pretty good examples in here already. The other thing that's super important is when you're setting up your event mapping. This is mapping API gateway to your Lambda function. You need to make sure that you're using a /proxy route on your API. And this will just tell API gateway to pass every single request onto your Lambda function. Now, equally, this could be /orders proxy or /users proxy. And in this situation, all of these requests will then get passed onto this single Lambda function, your API running on Lambda. Of course, one of the benefits of doing this is your developer experience as a developer. You can just run this on localhost the same way you always had, run your tests locally, develop against it. When you're ready, package it up, ship that, it'll run on Lambda absolutely fine. The other thing to think about, which is slightly more nuanced, because you're running an entire web framework on Lambda, typically your cold start times are going to be slower. And that's one of the common criticisms you will see with this approach, is that when you do get a cold start, that cold start is going to be slower. And that was some of the responses I have to my tweet on Twitter. But actually, although you might see slower cold starts, typically you're going to see less cold starts, because you've got multiple routes. Let's say your API's got 10 routes and they're all routing to the same Lambda function, the same underlying function. Actually, you're going to see less cold starts, which is a really interesting dynamic. If you've got an API under any kind of reasonable load, this can be a really good approach. And I know of customers who've had a lot of success with this approach, moving from single purpose handlers in the traditional sense through to combining multiple handlers into a similar function with a similar API. Of course, Lambda Web Adapter does allow a little bit of configuration. If we come back to the GitHub repo, back to the root, And there is a whole bunch of environment variables you can set somewhere in here. And I'm just going to zoom out a touch so we can actually see these. There's a whole bunch of different settings to actually manipulate how Lambda Web Adapter works. So by default, it will look for localhost 8080. You can configure that if you need to use a different port. You can use a port for health checks, a different path for your health checks. You can change the protocol, change what status code determines health or unhealthiness. You can do async and init. So there's a whole bunch of different things you can do to actually configure how Lambda Web Adapter works. And I'd really recommend actually going to check this out to have a look at how you can actually do these things. You can get access to your request context, the actual HTTP headers and things like that, the Lambda context, the actual contextual information about Lambda itself. So there's a whole load of different examples here. And of course, this will also work if you're packaging your Lambda functions as a container. And it actually makes it possible to run the exact same container image on something like Fargate as well as in Lambda. If I have a look at this .NET example for ASP.NET and we look at the Docker file here, you'll notice that one of the steps of the final stage of my build is to actually copy in the Lambda Web Adapter. So now when this starts up and it runs within Fargate or within a container, well, it's just going to start up using the entry point here. Lambda Web Adapter might start, but it's not actually going to do anything. Lambda Web Adapter is not actually going to do anything because there's nothing that's going to run it because the Fargate doesn't understand the concept of extensions and Lambda extensions. So it'll just sit there and it might inflate the size of your container image slightly, but it's just going to sit there. You deploy this exact same container image into Lambda, all of this code for the Lambda Web Adapter kicks in, and it will then start passing requests from the Lambda Runtime API into your actual HTTP web application. I don't want you to just take my word for this. I want to actually demonstrate to you that this is happening. So if I grab the API URL of that deployed API, and if you remember, I've set the base path to be /users, so I'm going to have to include that. So if I do /users/health, which is an endpoint on my API, I get a response. Now, I do have some really basic authentication on this API, so it's not actually going to work. But this is a response that's being returned from my Rust application, and it is my unauthorized response that the user ID needs to be configured. And that really is all there is to it, to running your web applications on Lambda. Of course, you need to make sure that your applications are stateless. If you've got a stateful, and when I say stateful, I mean stuff in memory in your application, this probably isn't going to quite work because of the nature of how Lambda execution environments work, and there being no way you can guarantee that two requests from the same user are going to hit the same backend of Lambda. It's pretty likely that they won't under any kind of load. But actually, if you've got web applications that you need to scale to zero, that a little bit of startup latency isn't going to cause you too much of an issue. For example, the .NET example that I've got in here typically takes about a second, maybe 1.5 seconds to start up at cold start. For many applications, especially internal applications that aren't public facing, that could be absolutely fine when you consider the benefits that you can really easily deploy, scale back to zero when no work is being done. So that's the AWS Lambda Web Adapter. I'd really encourage you checking it out. If you're just interested in how you can run web applications on Lambda, how you can have multiple routes routing to the same function and still use a web framework that you know and love. See you all in the next video.